So I thought I could make a quick video to show you kind of what I'm looking for how to figure out the parent acid, the parent base, and the K statements afterwards. So I'm going to choose an example of LiCl, which is similar to what you had. So what I'm going to do first is figure out that parent acid. So what I'm going to do is I'm going to split up that lithium and the chlorine into their own ions to figure out the parent acid and the parent base. Again, I'm going to see who's attracted to the H and who's attracted to the O. Okay, so here I found that my parent acid is HCl, my parent base is LiOH. So if I look at my list of 7 strong acids, I realize that HCl is a strong acid. And if I look at my list of strong bases, lithium's a group 1, and so that would be a strong base. So since these are both strong, I would assume that these would neutralize each other. So my predicted pH would have been a 7. And so my universal indicator color probably was a green-ish. And hopefully when I test with the pH paper, I find it to be about 7. Now, most likely this is just going to be an electrolytic solution. So we're just verifying that. So NaCl in a water solution should conduct electricity. And I put strong, weak, or non-electrolytic just to see. My guess is it would show strongly electrolytic. So now I want to show you what I would write for that ionic reaction part. So I had given you a hint of writing the salt solution plus water. And then we're going to get that hydrochloric acid and NaOH. And so then we're going to write this as a net ionic. So these are going to split up. Water stays together. Strong acids split up. And strong bases split up. So my net ionic, if I figure out who goes away, okay, there should be LiOH. You can tell my brain is not on there. Okay, so the lithium would also go away. And so what I'm left with on my net ionic is H plus OH minus. So if I'm to write a Ka, Kb, or Kw, this would be a Kw because this is for water. So it is a neutral solution of H plus times OH minus. Okay, so that's what I'm expecting for the post-lab question is this is your net ionic, and then notice the Kw statement at the end. So let's go ahead and do one more. Let's choose different kind of salt. So for this one, I have KC2H3O2, so potassium acetate. So my parent acid on this one is HC2H3O2, and my parent base is going to be KOH. That guy's a strong base. This is a weak acid. So I'd predict this to be a basic solution. I can call it 9. So let's say it's blue. Let's say it's actually 10. It's probably going to be electrolytic because we got a saltwater solution again. So this is just to make sure you still know how to use the electrolysis stuff. We'll get more into the strengths later. So I can go ahead and write my ionic. So Kc2H3O2 plus water is going to make, I'm going to put my strong base, and I'm going to put my weak acid. So then I'm able to split up my salt solution, keep water together, split up the strong base, keep the weak acid together. So just a reminder that weak acids and weak bases will stay together. That K is going to go away. So my net ionic at the end is C2H3O2 minus 1 plus water. And it's going to yield that OH minus 1 plus HC2H3O2. So looking at this reaction, I'm looking at my products. I see that hydroxide ion. Because it's a hydroxide ion, this is going to be a Kb. So this would be OH minus 1 times HC2H3O2, all divided by that acetate ion. So this is just like what we would write for a typical KB problem, and this could be that salt solution that we see that ends up being a KB. Hopefully this helps you with the lab.